Thank you, Joe. It is great to be here, and thank you, PyTorch Conference. I'm excited to be here to talk. I only have a few minutes. I'm used to talking longer, so I'll go really fast. If you missed something, come see us at our booth, and we'll talk a little more. Appreciate the talk by Stella. We're going to continue with this discussion of interoperability. So we talked about my latest adventures, but previous to that, I spent a long time in the scientific array computing world. Started the SciPy project as a graduate student, then wrote NumPy as a professor, essentially trying to give scientists tools to do what they want to do. Now, pandas came later, then Numba and Dask are acceleration capabilities. Numba is a compiler, Dask is a distributed array computing and data frame computing system. These are all libraries that have been growing in the ecosystem. Then all of a sudden, they sort of formed a foundation for science. In fact, one estimate says that 25% of all science is done by these tools. It's an amazing statistic if you kind of look at the papers that are being run. Things like black holes and the gravitational waves have been discovered. Now, about 2015, 2016, the deep learning libraries started to emerge, where all of a sudden this promise of incredible power from stitching a bunch of arrays together at scale and putting it on GPUs and doing GPU calculations really started to take over, and things like TensorFlow and PyTorch started to emerge and started to drive a lot of the discussion. Now, we've shown diagrams like this in the community for a long time, how there's a foundation of libraries that work together, NumPy, SciPy at the bottom, and then TensorFlow, PyTorch at the top. As we've been seeing things, it's actually, PyTorch is becoming kind of a central point in a lot of array computing. It's no longer, this is the wrong diagram, essentially. PyTorch should be driving farther and farther down the stack, but to do that, it's got to be able to work with the libraries that exist. Scikit-learn, SciPy, any number of ML models, MLPack, and so forth, they all want to potentially use the power of the Torch compile, the power to go to GPU and to TPU. How do we make that possible? So we've been working for a while at Quansight Labs on this data API standard. And you go to https://data.apis.org, and it's effectively, when I noticed this happening, and long ago I wrote NumPy to merge NumArray and Numeric, which are two array libraries, into one to help this fledgling community grow. Fast forward to 2016, 17, and the array community is fractured even more. And so what do we do, and how do we do it? The idea was to actually create a standard, an array standard, and a data frame standard, and start working on that. We did it as a consortium, Quansight Labs kind of leading, and with many other folks sponsoring and helping. And the focus being on interoperability, allowing libraries to work together, really focusing on interoperability to make it easy for domain experts, people that just want to get their stuff done, to get code to run without worrying about, well, which library was this, which hardware, which stack do we have to worry about, can they all work together well? Making it familiar. There's a lot of mental energy a lot of people have had using the NumPy Array API, the NumPy API, Pandas APIs, so people don't have to learn a new user interface in order to do the computing they want on a GPU, and minimally invasive. So this led to PyTorch as an Array API backend. So fortunately, we've been working with Meta for several years. We have a large team working on PyTorch and helping connect it to the ecosystem of array computing that's SciPy and the PyData ecosystem. And so PyTorch is an array backend, making sure it's compatible, making sure that the learning curve is still small. That's one of the reasons PyTorch grew in popularity, because it wasn't a large learning curve for somebody already familiar with Python array processing. They could just plug PyTorch in. The features, though, are key, making sure it works on CPU, GPU, potential new hardware coming out, and then automatic differentiation, of course, being a clear reason people like to see complex models built with PyTorch. And making sure you can build an ecosystem where PyTorch stays focusing on what it does well, allowing everything else to do what it does well. So this is an example of kind of what it means to have this data array, this backend that allows you to specify in scikit-learn, set the configuration to array API dispatch. Once you do that and you import Torch, then you can actually have a Torch array and then pass that into a standard scikit-learn function. And it'll know that it actually can call PyTorch on the back end instead of NumPy where it was originally coded for. So with small changes to scikit-learn, small changes upstream, and this array API compatibility library, you can get quickly your code running on PyTorch. And for this example, and this was shown earlier this morning, you can actually get really fast code working. So that's what we're doing. We're excited to kind of continue with interoperability. Come see us at Quansight. We provide services to help you connect your hardware to PyTorch and also help you use PyTorch more effectively and help you build generative AI and do large language model services as well. Thank you so much. It's been great to be here, and come talk to me at the booth.